Okay, let's dive into this. Welcome to The Explainer. Today, we're unpacking a paradigm-shifting concept that completely reimagines one of the absolute greatest cosmic mysteries of our time. Think about it. We've spent decades building massive underground detectors, launching multi-billion-dollar satellites, just endlessly searching for these invisible particles to explain the structure of the universe. But what if we've been looking at it all wrong? What if the universe isn't actually missing anything at all?
Seriously, what if dark matter isn't actually matter at all? It's a massive, almost unsettling thought, right? Because for years, astrophysicists have told us that over 80% of the matter in the universe is just invisible, completely missing. But a groundbreaking new paper is suggesting that this missing mass might not be physical particles hiding in the dark, but rather a profound dimensional illusion. Basically, a giant glitch in how we observe reality itself.
Section 1. The Dark Matter Illusion. So, we're about to look at the universe through a completely different conceptual lens. Enter researcher Melvin Sewell from the Cosmic University of Echo-Rift Studies. Sewell has proposed this radical new idea called the scalar X framework, and it redefines the very nature of what we observe in the night sky. He's saying dark matter is not some absent physical particle we need to catch. Instead, it's a misrecognized scalar distortion. So rather than acting like cosmic ghost hunters searching for invisible particles floating in space, Sewell argues we need to understand how the universe's baseline reality is literally being mathematically distorted before the light and gravity even reach our telescopes.
Just listen to this quote from the paper. Sewell writes, "Dark matter is a functorial misalignment within scalar reality." Man, that gives me chills just thinking about the implications. What this research does is bridge cosmology, quantum topology, and abstract algebra to suggest something incredibly wild. We are essentially looking through a distorted cosmic lens. The universe isn't missing a bunch of hidden matter. Our observational framework is just fundamentally misaligned with true reality.
Section 2. Enter the scalar X framework.
Okay, now I know what you're thinking, but don't let the high-level math intimidate you. We're going to break this complex algebra down into totally accessible visual steps. Let's start with Sewell's original operator algebra equation, m prime equals x times m. So m represents the baseline mass. That's the actual, true, physical stuff in the universe doing exactly what it's supposed to do. M prime is the misrecognized mass. That's the distorted version we actually see from Earth and mistakenly label as dark matter. And x? Well, x is the star of the show. That is the recognition operator. This x acts as a modifier, distorting the baseline mass and creating the illusion of this extra gravitational pull that simply isn't there.
But here's the catch. Sewell realized his simple algebraic formula lacked what he calls universality. To truly describe the entire universe, he had to upgrade his framework using category theory. Now, as a quick refresher, category theory is a highly generalized mathematical framework. It's focused on mapping relationships and structures between entire categories of objects, rather than just isolated variables. By elevating his math to category theory, Sewell achieved the universality he needed to systematically map out the precise translation errors that happen between entire dimensions of reality.
Section 3. Category theory and mass.
Now, what's really interesting about this slide is how Sewell uses category theory to fundamentally divide our universe into two distinct realities. I want you to really visualize this split. On one side, we have category M. This is the invisible true reality, the baseline mass energy. It contains the true galaxies and their authentic gravitational interactions, the universe as it physically exists. But on the other side, we have category M prime. This is the misrecognized mass, the illusion. It's the distorted galactic profiles and the anomalous gravitational lensing that we actually observe through our instruments, the phenomena we've literally always blamed on dark matter.
So, how exactly do we get from the true reality of category M to the distorted illusion of category M prime? Well, enter functor X. The recognition operator from earlier has evolved into a functor. In this context, a functor is basically a mapping tool. It takes the true mass structures in category M and maps them directly into their distorted observational counterparts in category M prime. Think of functor X as a highly flawed piece of cosmic glass. Gravity passes through it, the properties get mapped incorrectly onto our dimension, and boom, we calculate a massive excess of mass that doesn't actually exist in the baseline reality.
Section 4. The oscillation collapse.
So, what forces this distortion to lock in and become our perceived reality? Well, it's a mechanism called the oscillation collapse. Here is how it unfolds in 3 specific steps. Step 1. The baseline mass happily exists in its true undisturbed form within category M.
Step 2, functor x applies that mathematical distortion, mapping it over to category M prime. But step 3 is the absolute crucial point. Dimensional oscillations collapse upon the very act of observation. When we look out into the cosmos, we force a reconciliation of that distortion. Our act of observing essentially freezes the functorial misalignment into the distorted reality we measure and call dark matter.
Sewell actually models this collapse mathematically as a natural transformation. You see that Greek letter eta? It represents the transformation of the recognition functor x into I, which stands for the identity functor on category M. Now, I know it might look like just a few abstract symbols, but what this equation elegantly describes is the exact moment the distorted recognition is forced to reconcile with baseline mass energy. It is literally the mathematical footprint of how observation creates the dark matter illusion.
And this brilliantly illustrates our next point, Section 5, Mapping the Multiverse.
Let's zoom out our perspective for a minute. If observation causes a scalar distortion in our universe, what about the spaces beyond it? Well, the paper introduces the SMI model, Structured Multiversal Interactions. It's an incredible model where layered dimensional levels interact via these exact same recognition functors and oscillation collapses. Sewell takes this concept of functorial misalignment and extends it into higher category multiversal structures. So we're no longer just talking about a glitch in the galaxies of our night sky, we are talking about mapping the mathematical architecture of the entire multiverse.
Let's detail these parameters to show just how these complex higher category interactions bridge dimensional levels. First, it introduces multiversal sovereignty, suggesting different dimensional layers maintain their own distinct structural rules, but they interact through these recognition distortions. Next, we see layered dimensional levels. In this higher math framework, those oscillation collapses we just talked about act as what category theory calls two-morphisms, essentially mapping the relationships between the distortions themselves. Finally, it seamlessly connects multiple multiversal frames. It's just a breathtakingly structured way to view the cosmos.
Section 6. A new cosmological reality.
All right, let's synthesize this abstract algebra and bring it all back down to Earth. What does this actually mean for our understanding of reality? The core takeaway from Sewell's research is that it provides a rigorous mathematical foundation for multiversal sovereignty and recognition distortion. So here is the big so what. We aren't missing the vast majority of the mass in the universe. We can finally stop searching for physical ghost particles. Instead, we are looking at a mathematically predictable structural misrecognition. The math proves that the missing dark matter is just a shadow cast by the functorial interaction between dimensional layers. Which leaves us staring down a truly mind-bending final thought to close out this explainer. If our universe, as we observe it every single day, is just a misrecognized projection, what does true baseline reality actually look like? Think about it. If we could somehow strip away functor x, if we could completely bypass the oscillation collapse, what would the true mass energy of the cosmos look like to the naked eye? Sewell's paper challenges the very fabric of how we observe the world. I really hope this structured dive into scalar reality leaves you just as hungry as I am to explore more about quantum topology and the magnificent hidden nature of our universe. Thanks for learning with me today.